body contains a lot of water, and most of this water exists in specialized aqueous solutions. These solutions throughout our body are separated by cell membranes, which are semi-permeable, which means some molecules can pass through the cell membrane and others cannot. Water can definitely pass through the cell membrane. Under normal physiological conditions, the solution inside the cells has the same concentration of dissolved solutes as the solution outside the cells, and that's what's known as isotonic, when the concentration of solutes is the same within a cell and outside the cell. However, if the concentration of solute changes, then water will travel through the membrane through a process known as osmosis in an attempt to equalize the concentration of solutes on both sides. So, for example, if someone drank a large quantity of water and ended up diluting the blood, the concentrations of solutes outside the cells in the blood would be hypotonic, or lower than what was inside the cell. Water will then travel through the cell membrane into the cell in an attempt to equalize the concentration, to make the concentration inside the cell lower, so it will be the same as the concentration of solutes outside the cell. So if too much water enters the cell, then the cell could end up bursting, and when the cells swell up, that is a process known as hemolysis. Now, as water flows through a semi-permeable membrane, the force exerted by that flowing is known as osmotic pressure, and that osmotic pressure depends on the concentration of the solution. The higher the concentration of the solution, the higher the osmotic pressure, and pure water has an osmotic pressure of 0. Now we've seen isotonic and hypotonic. Let's look at the other situation where the concentration of dissolved ions is higher than that in the cell. And an example of that is seawater. So for example, if we drink water, then the concentration of dissolved solutes in the bloodstream would increase, and therefore there would be more solutes in the blood than in the blood cells. And this is what's known as a hypertonic solution. And so what would happen is water would travel from the cells to the bloodstream in an attempt to lower the concentration of the blood. And this process is known as crenation. And if you were ever to drink seawater, you would become dehydrated due to this process. This slide shows a cell in an isotonic solution, a hypotonic solution, and a hypertonic solution. So in a hypotonic solution, the concentration of solutes is higher in the cell, and water is going to travel from the solution into the cell, increasing the volume of the cell. In a hypertonic solution, the concentration of solutes is higher in the solution than the cell, and water is going to leave the cell through osmosis and a process known as crenation. But in an isotonic solution, water is flowing in and out at the same rate. There's no osmotic pressure because there's no difference in concentrations.